Hello, grade 12s. Today we're going to start proportionality. It's in those blue or green books that we gave to you. I'm going to be working from slides 1 to 9 in the PowerPoint Proportionality Geometry 1. So if we look on that first page of yours, they're giving some definitions of ratios, proportions, and stuff like that. So if we look at a ratio is the relative size of two quantities expressed as the quotient of one divided by the other. So generally that is how we write a ratio, 7 to 4, okay? What this actually means, it means 7 over 4, and that's how we can write a ratio. Then if we look at a proportion is a relationship or equality between two ratios. Four quantities are in proportion if we say AB is equal to C to D. So we know that this is a ratio from this. So we know that would be A to B, and this is a ratio from this C to D. So we have a proportion here of A to B is equal to C to D. And a nice simple example is 3 to 6 is equal to 1 over 2. We can just simplify that and get a half. Now, if we look at this proportion here, this A to B equals C to D, we know that A and D are the extremes. They're the ones on the end, and that's why they're called extremes. Then B and C are called the means, these two. Why? Because they lie in the middle of these numbers. Then D, this whatever this number is called the fourth proportional. And then B over here is the second proportional. Okay. The next slide is talking about invertendo, alternendo, componendo, and dividendo. You guys can run through it, look at it. This isn't Hogwarts. I'm not interested in Expelliarmus and stuff like this. So you guys can just have a look at that and see what they're saying there, but I'm not too interested in that. Okay. So now, if we go to the next slide, we've got some examples to look at. And they are asking us, they're saying, determine the value of x in each of the following proportions. So if we look at this first one over here, we have 3 to x is equal to 4 to 10. So what I can do here is I can multiply up, just like a normal equation. So if I multiply that up with that, I will get 4x is equal to that with that, I get 30. Then what I can do is just divide through by the 4, and I can get x is equal to 7.5. Pretty easy. I'm going to do exactly the same thing with this one. Multiply up by the 6, multiply up by the 3, and we get 6x equals 78. Divide by 6, and we get x is equal to 13. Very similar here. Multiply up by the x, multiply up by the 24, and we get x squared is equal to 144. I'm now going to take the square root. Now remember grade 12s, if you take the square root, it must be plus or minus. So we'll get here x is equal to plus or minus 12. Okay. Next one, very similar. Multiply up by the 7, multiply up by that x plus 5. Grade 12s, I'm going to miss a step. As you know, this is going to be 7 bracket x minus 5. Then I'm just going to distribute the 7 in. So I'm going to just miss that step. So we would get 7x minus 35 is equal to, very similar to this, we're going to get 3 bracket x plus 5, and then I just distribute the 3 in. So I'm just going to miss that step, and we get 3x plus 15. Okay, take x's to the one side, numbers to the other. So this would give us 4x is equal to 50. Divide through by the 4, and we get x is equal to 12.5. Okay, last two, very similar. Multiply up by the 21, multiply up by the x plus 2. So here we would get 21x is equal to 15 bracket x plus 2, distribute the 15 in, and we get 15x plus 30. X is one side, numbers the other side. So I take that to this side, and I get 6x is equal to 30. divide through by the 6, and we get x is equal to 5. Okay, very similar here. Multiply up by the 21, multiply up by the x plus 4, and then distribute the x in. So I'm going to do that over here, and we get x squared plus 4x equals 21. Take everything to the one side because then we have a trinomial. So we have x squared plus 4x minus 21 equals 0. We can factorize this, and we get x plus 7, x minus 3. So that means that x is equal to minus 7, or x is equal to 3. Right, second example is asking us, determine the fourth proportional of 2, 5, and 8. Now you remember from our very first page here, the fourth proportional is this D. D is the fourth proportional. So they're asking us, what is that number over there? So, because it's the fourth proportional, I know this is going to be 2 to 5 must be equal to 8 to x, where x is your fourth proportional. Multiply up by the x, multiply up by the 5, and we get 2x is equal to 40. Divide by the 2, so x is equal to 20. That is your fourth proportional. Question 3, determine the mean proportional of 4 and 36. So, going back to your first page, remember that the mean are two things. It's either the B or the C, the second or the third thing. Okay, and I'm going to set it up like this. So we want the mean, so it is this one. 4 over x equals x over 36. Multiply up by the x, multiply up by the 36, x squared equals 144. You can take the square root and you get x is equal to plus or minus 12. Okay, moving on to example 4. It is asking us here, determine the possible proportions from which the following were determined. So this is the reverse of what we were doing over here. So basically, we were at this step, and now we've got to work backwards. So there are 4 possible outcomes that we can get here. We can keep the a at the top and divide through by the c. Then keep the d at the top, because we've got rid of the c, and then divide by the b. That's one option. Another option could be to keep the b at the top, divide through by the c, keep the d at the top, and divide through by the a. Another possibility could be we could keep the c at the top, divide by the a, keep the b at the top, and divide by the d. Or another possibility, we keep the a at the top, divide by the d, keep the c at the top, and divide by the b. So we have 4 different possibilities from this. We'll have the same scenario over here. I can keep the AB at the top and divide by PQ. And then we would have the MN left over there, and we would have to divide by CD. Another possibility could be we keep the AB at the top and divide by the MN this time instead of the PQ. Then we would have the PQ left over, and we would have to divide by the CD. All right, another possibility is keeping the CD at the top and dividing through by MN. And then we would have to leave the PQ up at the top and divide by the AB. Another possibility could be keeping the CD at the top, dividing by the PQ, keeping the MN at the top, and dividing by the AB. Very similar to that one. Now this one over here is exactly the same as this one. It's just written in a funny way. This AB squared is actually AB times AB would be equal to AC times BC. So it's exactly the same as this one, just written differently. Okay, so with this one, we'll only get two outcomes. We can keep the AB at the top and divide by the AC. That means we're left with the BC over there, and we have to divide by AB. Or we can keep the other AB at the top and divide by the BC. And then that means we'd have the AC at the top divided by the other AB. And there's our two possibilities for that. Looking at example 5. Okay, example 5 is saying that ABCDE is a line segment that has been divided so that AB to BC to CD to DE is equal to this 1 to 3 to 2 to 5. And then they're just asking us what are the ratios of these down here. So first of all, what I'm going to do is I'm going to draw my line segment. Okay, and we have A, B, C, D, and then E. Now grade 12s, initially it doesn't make a difference where I put these letters. I'm just guessing more or less. Okay, I'm just looking at the numbers here. But an exact length is not necessary. So I know AB is this ratio 1. I know that BC is the second one, is 3. CD is 2. And then DE, which is this last one, is 5. Now you can see more or less how I judged the length of my lines just by looking at those ratios. Okay, so now they're asking us, what is the ratio AB to BD? So AB is 1, 2, and BD is going from here to here. So we have 3 parts, 2 parts, a total of 5 parts. If we look at this one, AB is 1. And if we look at AE, from there to there, we have 1 part, 3 parts, 2 parts, 5 parts. If we add all of these up, we should get, that's 4, 6, 11. Okay, then AC is that, so it's 1 part, 3 parts, gives us 4 parts. Then C to E is 2 parts, 5 parts, so we get 7. Then we've got BE going from there to there, so we have 3 parts, 2 parts, 5 parts. That'll give us 10. Now, be very careful how they've labeled this. They're telling us that we're going from E to C. Okay, so we're going in this direction now. So E to C is 5 parts to 2 parts, so that'll give us 7. But because we're going in this direction, it is negative. Okay, next one, we're going from E to B, from there to there. So it is 5 parts, 2 parts, 3 parts, so we get 10 parts. But be careful with the direction. We're going from E to B, so this will be negative. Okay, then we're going from A to D, so we're going in this direction, so it's going to be positive. So we've got 1 part, 3 part, 2 parts. That'll give us 6. Now, whenever you're dealing with ratios, grade 12s, you need to simplify them, put them in their simplest form. So with this one, I can see that 2 is common with both of them, and you'll notice with the rest of the other ones, there was nothing that we could really do to simplify it. So I know that 2 goes into both of these, so the simplest form would be minus 5 to 3. Okay, then we've got ED from there to there is 5, going in the other direction. And then we've got from D to B. D to B, we've got 2 parts, 3 parts, will give us minus 5 as well. Then minus 5 goes into both of these, so our simplest would be 1 to 1. Okay, moving on to example 6. So example 6 says, T divides a line segment PQ, here's our line segment PQ, which is 20 centimeters long, in the ratio 3 to 2. Okay, so I know somewhere along here we're going to have a point T, and it breaks our PQ line in the ratio 3 to 2. Now, grade 12, this does not mean 3 centimeters to 2 centimeters. You can clearly see that that does not add up to 20. It has just broken it up into a ratio of 3 parts to 2 parts. Okay, now what we need to do is determine the lengths of PT and TQ. So what I can do here is I can say that PT would be equal to, now we know that PT is 3 parts out of a total of 5 parts. 3 plus 2 gives us that 5. So it's 3 parts out of the 5 of the total length of our line segment. So 3 parts out of 5 of our total length. And that will give us 12 centimeters. So now that I know that PT is 12 centimeters, that's easy to work out TQ. So therefore, TQ must be equal to this 20 minus the 12, and we get 8 centimeters. Grade 12s, I would like you to do exercise 1 in your books for me, please. Thank you.